All right, this video is 2.4 to 2.5 notes. We are going to be talking about complex and irrational zeros, things like that. It's going to be a little tricky, but not too bad. Basically, just kind of bringing the quadratic formula back into play here. So if we look at this, it's really it's pretty straightforward. Like if you look at this, does it factor? Is it factorable? I want to give you a nice little reminder that you can use the discriminant to see if it's factorable. So quickly, you can kind of just do b squared minus 4ac. This will tell you if it's factorable immediately. So if you take b, which is -2, and you square it, you have 4 minus 4 times 3 times 5. And that's 4 minus, that's like minus 60, I think. So if this is going to come out negative, this was actually under the square root of the quadratic formula, right? So if this come out negative, this is probably going to be an imaginary solution. So I know right away that this is a quadratic and I have to use the quadratic formula. So I'm going to use negative b plus or minus the square root of. B squared minus 4ac we already just did. It's negative 56 all over 2a. So that's what x is going to equal. So that's going to equal 2 plus or minus I root 56. But maybe we can think of what 56 will break into. I think 4 goes into it, yeah? So 4 goes into that 14 times, maybe? Does that sound right to you? 14 times 4? Yeah. So it's I square root of 4, square root of 14, still all over 6. This is basically review, right? And you did imaginary solutions, I got to believe, yes, in Algebra 2. I'd be shocked if you did not. Yeah? Okay, cool. Just checking with my group here. So that means I have 2 plus or minus 2i root 14. 14 is 7 times 2, so I don't think that's going to go anywhere to 6. Now here's the thing. This is where people make a lot of mistakes, is the simplifying. When you simplify this, you need to be careful that if you're going to divide, you're dividing, this is one term, this is a second term, and this is a third term. You can divide them all by 2. Gives you 1, gives you 1, gives you 3. So it's going to be 1 plus or minus I root 14 over 3. 1 plus or minus I root 14 over 3. And if you needed to write that in 2, which sometimes you do, sometimes you don't, it's 1 plus I root 14 all over 3. That's one answer. And then your other answer is 1 minus I root 14 all over 3. So could you pause the video and give this problem a try? Give this problem a try. You can use a calculator if you need to. It gets a little bit big. It looks like those numbers are going to get big, but they're not too bad. All right, so hopefully you paused the video and you tried that. The answer for this came out to, I believe, -7 over 8 plus or minus root 23. I like to put the I in front of it. That's just me. But the book put it as root 23 over 8, and then they put the I here. Of course, you can put the I right there if you want. So these are your two answers for x. Hopefully that's all right. Are there any questions in the room here? Okay. Because if you have a question, somebody on the video watching it at home will have a question for sure. Okay. So next we'll get into the fundamental theorem of algebra. It seems like it's going to be such a big deal because it's called the fundamental theorem of algebra. It's not really. It's basically just saying that they're all going to have at least a 0, basically. So if you have a polynomial with degree bigger than, 1 or bigger, I guess, right? If you have a polynomial, you're going to have a 0, whether it's real or imaginary, right? That's what they mean by complex. So it could have a real or imaginary. So even though it has an imaginary solution, it's still called a solution. And there's some complexities with that. We don't get into that. It's beyond this course. But what you need to know is that you really do have n factors if it's degree n. You really do have n factors, but these could be complex. They could be complex. So basically what I'm trying to say is that not only do you have a degree 5 has 5 roots, it does, but it could have 5 real roots or it could have less than that, but it has 5 roots total, real and imaginary. Okay? If it's degree 8, it has 8 roots, real and imaginary. It could have 8 real roots. It could have perhaps 8 imaginary roots. I haven't really seen that before. So that's sort of where we're at. Okay, that timer's not even close, I don't think. So let's keep moving through this. So now we're getting into finding the real solutions of a polynomial, right? And we don't know how to really handle this aside from start with our rational root theorem, right? So that's what we're going to do. We're going to think about our rational root theorem, and then we're just going to go for it. And I think, my gut tells me this is not going to be our most enjoyable equation problem that we've done this year, but I think we can do it. So I'm going to put the factors of this guy over here. So that's going to be plus or minus 12, plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3, plus or minus 4. And I try to think if there's any others. I don't think there are, because we already covered 3. We got 1, 2, 3, 4. 5 doesn't go in. 7 doesn't go in. So I think we're covered. Then I'm going to go over here. I've got plus or minus 10. I got plus or minus 1. I got plus or minus 5. I got plus or minus 2. This is just my system. These are prime, so I think that might be it, actually, once again. Okay, so let's talk about options. Well, we could list everything out if we wanted, obviously, but I will just start synthetic dividing. Personally, I'm just going to start synthetic dividing by 1 and 2, because I know I'm going to have 1 over 1 and 2 over 1, plus and minus. And if one of those 4 things doesn't work, then we'll talk about it. But I think one of them will probably work. That's just my guess. Now, there might be other ways to tackle this. I wonder if you could get it by grouping. I don't think you can, but it looks like you almost could, but it doesn't quite look like it's going to work. But if you could, then that's fine. So this is always going to be negative 10, 15, 16, negative 12. Okay. So we'll start with 1, negative 10, negative 10, 5, 5. If I make a mistake, please let me know here. 21, 21, not a remainder of 0. So I would say that 1 is not there. So if you want, you could do this and just be like, nope, it's not 1. Okay, cool. So now we erase. I put this in pen so I can just erase the other part here. And we'll try negative 1, right? Logically. It's not really any different. You're just going to find that we'll probably have a complex solution at the end. So this is going to be 10, 25. Let me know if you see me make a mistake here, because it definitely is possible. Negative 9, 9 didn't work, right? So negative 1 didn't work. Bless you. I'm going to be very sad if 2 and negative 2 don't work, but we'll see. I'm not looking at the answer. I'm just kind of modeling what I would do if I was taking a test and this problem was on it. Let's try positive 2, I guess. Negative 10, negative 20, negative 5, negative 10, 6, 12, 0. Yes, we hit 1. So what that means to me is that since 2 worked, that means that x plus 2 times negative 10x squared minus 5x plus 6 is a rewrite of this. So this can be rewritten as this. Okay, that's good. We'll now need to break that one down. Does it factor? I doubt it. Yes. Oh, yes, you're right. I actually, in my brain, thought of that too. I was like, make sure you get the sign right. Thank you. Let's look at the discriminant. So just making sure that you guys realize I was reminded by a friend that this is x minus 2 because the root's positive 2. Let's just do the discriminant real quick. That's going to be b squared minus 4ac. See how that goes. B squared minus 4ac. Maybe like 2 or 3 more minutes. So that's going to be 25 minus 4 times negative 10 times 6. It's going to be a positive discriminant. I don't know if it's going to come out to a, let's see, 25. So when I know it's not imaginary, that's kind of good. This is 40 times 6. 4 times 6, 24. This is 240. I think this is 265. Does that have a square root? I have no idea. I will try to find it. So I'm just going to go ahead and do 265. If you want to see my calculator here, I'm just going to kind of divide it by 5. I can see it divides by 5. 53 seems prime to me. So I don't know that this will even have a square root. I hate that because it's so huge, but I think that's what we're dealing with right now. Because 5 times 53, they're both prime. So literally this is just 5 times 53. So I'm going to use the quadratic formula. I'm going to use negative b plus or minus the square root of b squared minus 4ac, which we already did, all over 2a. That's it. That's the answer. There's 2 answers, of course, so you could get them with a calculator, and I will show you just so you know what they are with a calculator. I'm not doing it out or anything, but one is going to be negative 1.064. We always round to how many decimal places? 3. Very good. And the other is 0.564. These are actual answers. They are not rational. They're irrational, right? So that's basically what's been added on today. Okay, so I would encourage you to pause the video and give this problem a try, finding all real solutions of this one. So pause it, and I will see you in the next video. Please try that problem. Make sure you smash that like button, subscribe, tick the notification bell so you don't miss out on any of our updates here. And be sure to visit mrpaseri.com for note sheets that accompany these videos. And we'll see you in the next video. Peace.